Here we go. We have a question. Minimum character to add for palindrome. So you have given a string. Our task is to find the minimum character to be added at the front to make the string palindrome. So you have given this string. If I add C then B, it will make palindrome. So characters we need is 2. In this case we only in this case we also need two characters. So if we add two characters before that, we have a palindrome. So let's try to build the approach. So let's take the input array itself, aa, then we have cec and 4 times a. So either this be a palindrome, or this be a palindrome, or this be a palindrome. In this case, this is a palindrome. So we only need to add two characters before that. But the brute force will give you TLE, so we somehow have to optimize this. So let's continue. Either this be a string, either this be a palindrome, this be a palindrome, this, 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 or this. So as you can see, this element, the starting position is constant, and after that, all the substring we have to calculate to index j, and j is greater than I but less than n. So one way to solve this question is to just add a dollar sign and just reverse this, aa aa cec aa, because starting and ending elements characters are equal in the palindrome. So as you can see, this character is equal to this character, so starting and ending is similar. Then we just need to find the LPS array. I will not gonna teach you about LPS array because yesterday I have already told you about the KMP algorithm, and in that we find LPS array. So I will just attach the video in the I button. So be sure to check out first. So till here we are not interested. After that we are interested. So is this character equal? Yes. Is this character equal? Is this character equal? No. So it will just move. Then we have this. So this is equal. Then we have this. So this is also equal. Then we have this AAC. AAC. So we have 3. Then this AACE 4. Then we have this AA AAC EC. Then we have 5. Then we have this. So we got 6. Then we got this AA. Yes. So then we got 7. So as you can see, this substring, we have this substring. This substring is palindrome. This substring is palindrome. How we detect? The character length, the substring length is 7. So 7 length till 7th length 1 1 2 2 3 4 5 6 7. 7th length substring is palindrome, and what's the total length? Total length is n. So if I subtract n minus this position, so LPS size is this is n, this is 1, and this is again n. So the last position, actually its length is 2n plus 1, so its last position is 2n. So n minus 2n, we got what we got? 9 minus 7, 2. We just need these two characters to add it first. So that's how this is a question. So that's how this algorithm will work. Let's try to code this. So first of all, what we have? We have n, I, j pointer and add. Then we have original string. I have added a character which is not present in a string, so it will just separate out these strings. Then I am first converting into string builder, I am then reversing the string and again converting it to string. Then we have LPS array. Then just we have a simple function fill, which I already discussed yesterday. Be sure to check out the video in the I button. So this is my LPS function. It will just fill out the LPS. Then just need to return n minus LPS, and I and j pointer we don't need, and we also don't need add. So that's how it will work. Let's give it a try. And in between, let's talk about time and space complexity. We have this, so it is reversing. Then we have order of n. Then for the LPS, we have fill function. It will just fill out, and inside the fill function we have two pointers, so it will work for order of n. Then we are just calculating. So the total time complexity is order of n. Space complexity is also order of n. We have solved this question, and we have also meet the expected time and space complexity. Code is given in the description box. Thank you all for watching.